So this assignment is reasoning with linear equations. When you guys are doing these problems, first thing you want to be able to do is you're comparing equation A and B. So it says A is equal to 5 equals negative 2 open parentheses x minus 2, and B is equal to 5 equals negative 2x plus 2. If we distribute that negative 2, we get negative 2x plus 2. And what you'll notice is that this equation right here is equal to this equation. Sorry, this expression. This expression is equal to this expression. So now we have two equal equations. So what did we do there? Looks like we multiplied, right? What did we multiply by? Negative 2. What is negative 2 considered to be? It's considered to be a non-zero constant. Okay, so we multiplied we actually multiplied not both sides of the same. We multiplied, oh, sorry, we didn't do both of them, sorry. We actually rewrote one side using the distributive property. All right, so we just did one side. We didn't do both sides. We did one side using the distributive property. Okay, so I'm going to say that since we use the distributive property. See here, based on the previous answer, the equation is equivalent. Yes, they have the same solution, so yes. All right, let's take a look at this one here. It says here's A. So we'll write A right here. 2x minus 1 equals 5x. That's equation A. Take a look at equation B here. Negative 1 equals 3x. All right, so we're trying to figure out if these two equations are equal. All right, now let's see here. If I took away 2x from this side and I took away 2x from this side, what would we get? Looks like we would get negative 1 equals 3x. So we get this is equal to this. So if these equations are equal, that means they're going to end up having the same solution. All right. So what did we do? It looks like we added or subtracted the same quantity to or from both sides. What did we subtract from both sides? Like we subtracted 2x from both sides. So that would be called same quantity. We just didn't do it to one side. We did it to both sides. We didn't rewrite it or by combining like terms, and we didn't use the distributive property. We added or subtracted the same quantity to both sides. So I'm going to say that guy. Okay, so these end up being the same solution. If we end up solving it, we divide both sides by 3. Divide that by 3. Divide by that by 3, and x equals negative 1/3. So they end up having the same solution. I'm going to say they added the same quantity both sides, and yes, they have the same solution. Okay. All right, so here's equation A, and we're going to compare it to equation B. There's equation A. Here's equation B. Equation A says 5x equals 20. Equation B says x equals 4. So if we divided this side and this side by the number 5, we get x equals 4. So now I have equivalent equations. But what did I do? I multiplied or divided both sides by the same non-zero constant. Multiplied both sides by the same variable expression now. So basically, the non-zero constant that I divided both sides by was a 5. So I divided, that's the key thing. I divided both sides of the equal sign. This is how did we get equation B from equation A? We got equation B from equation A by dividing both sides by a non-zero constant, and our constant was the number 5. And do they have the same solution? Yes, they have the same solution. All right, last question. All right, so here we go. Last problem. Let's take a look at this. So here I have equation A, and it says 3 parentheses x plus 2 equals 18. All right, and then over here, B, it says x plus 2 equals 18. All right, so how can we get B from A? Look here. Well, if I divide both sides by 3, those cancel out, and I'm left with x plus 2 equals 6, and x plus 2 equals 6 is not equal to x plus 2 equals 18. So how can we get B from A? Let me see if I distribute it. I get 3x plus 6. If I distribute the 3 to both of them, equals 18. Well, the only way to do it is, looks like I divided. The only way I could do this were to make them equal. Let me clear it out real quick. The only way I can get 3 parentheses x plus 2 equals 18 to somehow equal x plus 2 equals 18 is just to divide this side by 3, but not to divide the other side by 3. So I just have to divide one side by that 3 right there. So I could only divide one side by a non-zero constant to get the equations equal to each other. But these are not equal equations, all right? Because if I solve this, if I end up solving it correctly, how would I solve it correctly? This is how I would solve it correctly. Take away 6, take away 6, 3x equals 12, x equals 4. Over here, what number would you have to plug in there to make that equal? Not there. My apologies. What number would you have to plug in there? 16. So if you subtracted 2 from both sides, you get x equals 16. Well, 4 and 16 are not the same answer. So in order to get equation B from equation A, I would have to divide both sides by 3, which is only dividing one side. So my final answer is I only do one side, not both sides, one side. And heck no, these are not the same solution. All right. So in review, what do you guys have to do on this? You have to read the question carefully. You need to set A up. You need to set B up. Try to get B equal to A, and whatever you had to do to get B equal to A, that's going to be this answer. The second answer is whether they're equal, whether the equations are equal to each other. Well, these equations were equal to each other. These equations were equal to each other. The first equation, you could clearly see these were equal to each other. But the last equation, they were clearly not equal. These did not, I'm going to put an equal sign and a slash through it. They were not equal to each other. So that's why I chose no, they were not equal. And that's how you do it.